Hello, good morning. It is Wednesday, October 30th. I am Rob, that developer dad, and we're going to be continuing to make our validator or our validation engine closer to being ready for injection into a system. And then once this is done, I'm going to pivot back to doing the design aspects of that SaaS admin service that I need to be able to launch the DM's Familiar, and then we're going to start building that. And I should probably start focusing on the tasks for actually deploying the DM's Familiar into production environment this week as well. I had sort of an unstated goal of getting it live by Halloween, but that's tomorrow, and there's no way I'm going to be able to make that happen. So perhaps before Thanksgiving, American Thanksgiving. All right, so yesterday we got quite a bit done. We fleshed out we started fleshing out the validator class in the morning, and then started working on some unit tests for it in the afternoon. And of course, when we got to a unit test that requires that some rule sets exist within the validator, it started failing. No surprise there. And failing unit tests are fine. They happen. Sometimes they're even desirable, because it means we still have some work to do. So here we are. This is the one that didn't work. It's still not working. Pass valid test subject. The rule set exists, and we want it to evaluate as true. But when the rule evaluates, there's no rule sets. So it attaches a warning to the result and spits it back at us. And of course, actual is valid. While there may be no errors on it, there are warnings. So let's figure out why. Well, it's because our validator doesn't have any rule sets. So when that test hits this line, it creates a new result. It creates a rule set key, and then tries to get the list of validation rules out of its internal dictionary. And of course it doesn't get any because we haven't populated that dictionary yet. So in order to populate it, we need an instance of an RulesAccess component, which is to say we need a component that provides the behaviors described by this interface. And interfaces are like a contract. That just sort of describe the expectations and behavior that one component can have and must fulfill when communicating with another component or when collaborating with another component. So you can think of an interface as like a collaboration agreement. So we need to go into RulesAccess and see what's in there. So it needs to expose a method called loadRules of T with the subject type name. And I can't remember what the T is. I'm not sure why I specified that generic requirement. Oh, yes. T is the rule type. So, up here in the abstractions, because we've got two different kinds of rules. We've got just a regular rule definition, and we have a validation rule definition. Now, the difference between these two is that the rule definition will execute and return true or false, and that's it. The validation rule definition, if it executes false, it's going to return with, where are we? That's rule, here's validation rule. When a validation rule definition comes back, it's also going to include a failure message that is to be that's to be added to the list of error messages that come out in the validation result. That's right. So I want to enforce some type safety on this method. So what I'm going to do, and I don't do this often and I don't always advocate for it, but rule resource, and this is just going to be a marker interface. We're going to use this to identify and constrain the type of T so that load rules can only return an IEnumerable containing iRule resources. So now in order to get our different rule definitions to comply with that, we just need to say that these two definitions implement iRule resource. So I do want to add some commentary on here. Marker interface to describe any resource that can be retrieved by a RulesAccess service. There we go. Excuse me. Okay. So now down in our validation tests. We know our validation rules engine will only deal with validation rules. And let's go ahead so we've already got we've already got our dictionary up there. I'm going to hide that. It's being instantiated implicitly. So we need to, using that rules access, we need to initialize our dictionary. And I don't want to do this right inside the constructor because that'll get messy. So we've got our initialized rule sets. It's not declared. I don't know why that stuffed that down there. But I'm going to come down here and create a private void initialized rule sets. Close that method off. And One thing our validator is going to need to understand at the beginning of this process is an IEnumerable of type. Validation subject types. And let's just shorten that to subject types. Pop down to initialize rule sets, of course. Here we go. And IEnumerable. Here we go. We know we're looking for validation rules. So our output list from the access component will be IEnumerable validation rule definition. So now we don't need it to be a list. We could just use an IEnumerable. Get rules. And this needs a type name. Now, I'm gonna need to alter iRule resource. Nope, not resource. My bad. Resource access. What even? Here we go. IEnumerable of T load rules T IEnumerable of string where T is iRule resource. That looks like we're setting up for some repeated code, doesn't it? We're going to do something a little different about that. So, var subject type names equals. Just going to use a little bit of link to pull the name value out of the IEnumerable of subject types that we're going to be validating. And we're going to pass subject type names. Just in case there's multiples. Not get rules, load rules. Sometimes Copilot forgets where it is. It's okay. Now, we have a collection of validation rule definitions. Need to convert those into validation rule instances. All right. New validation rule. Okay. Now, does the validation rule definition also have failure message? It has. Good, good, good. Yeah. All right. So, Validator. Given that corresponds to the required parameter, blah, 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 blah. Yeah, that's fine. String activity context equals string failure message equals just an empty string and rule definition inner rule def equals and this is going to have a ambiguous reference. So, RulesAccess abstractions. Alias this. Excuse me. This using statement to fix an ambiguous reference. Okay, good enough. I just couldn't remember the exact syntax of doing that because I don't often. And I'm just going to get rid of RulesAccess or the word abstractions on there. And RulesAccess dot. What are you complaining about? Oh, hush. Storage. There. That'll shut it up. Initialize RulesAccess. Okay, so I got to change this to storage dot. down here. Back that out. So we've got activity context, failure message, and inner rule def. And what are you complaining about? It requires a simple rule. That's right. We're just going to comment that line out for now. Next, we turn the rule definition into a simple rule. Equals rule factory dot build rule. And it requires a rule definition. So we're going to need a new thing there. And instead of activity context, it's just going to take the inner rule, failure message, there we go. We have our instance. Subject type name is that rule definition dot activity name. Excuse me. We can just use the string activity context. There's that. And rule definition, utility definition equals new. And we're going to set that up in a second. I'm going to change inner rule def to storage rule def. Or just storage definition.
Wait, so
Build rule is going to take in the utility definition. That's a little bit more understandable. And now on that version of rule definition, we do have constructors. Good. So I can I need to pull this definition up and put it on the other screen for a second so that I've got my parameter list. Here we go. Subject type, name, storage definition dot subject type name, property type name, property name, operator kind name, and comparison constant. There we go. Good. And then we build the rule. Our validation rule is constructed from this inner executable rule and the failure message. We've got our activity context. And if try get value, get the rule set for that key. If it exists, we append the new rule to that existing list. Otherwise, we add it to the existing rule set key. And there's initialized rule sets. Cool. So there's all the infrastructure inside the validator class. And I'd kind of like to maybe clean this up a little bit, but it's fine. This is a lot untidy, but as long as it works, I need to start letting go of things that are so untidy and displeasing to my eyes. Because ultimately this is pretty readable. All right, so that's about as far as we can go here. So out to validation tests. Let's shrink that up. And in the test support namespace, I'm going to create a new file. It's going to be a class called fake RulesAccess. And it's going to inherit RulesAccess. No, don't generate the interface, you goose. Get lost. Using devdad dot RulesAccess dot abstractions. Save. What did I call that darn thing? Is it rules? Yes. Now I can implement it. Boop. Now, here we've got a place where we might end up creating multiple implementations of our code. Now, I believe in C#8, you can actually define a default implementation. So, string array, type names equals new subject type name Let's just let Copilot do its thing. And it's using a ternary if. Not in love with this construct. New argument exception must provide at least one subject type name. Name of subject type name. Okay. And then we're just gonna return load rules with type names. And we'll use that as a default implementation. So let's come over to fake access rules. And I'm gonna delete these guys. Goodbye. And now all we need to do is implement the one that remained abstract out on the interface definition. Okay. So we're going to have a because this is fake, I am going to private read only dictionary of string and IEnumerable I rule resource yeah. And I'm going to say for each string type name in subject type names and let's do a yield T rule. Can I do that? I don't want to, no. We're going to experiment with yield return in a little bit, but for now, list of T filtered rules is a new list of T. I'm going to comment this out and add myself a to-do. Come back once it's working. Experiment with this. Filtered rules.add T rule. Okie dokie. And then after our for each, return filtered rules. Yeah, okay. And yes, we have a nested loop. Ooh, scary. It is Halloween. Almost. All right. So let's come back to our fake rule access. And we need to populate this guy with some rules. So I'm going to need to, in the constructor, it's not going to have any parameters. And validation rule definition. Rule 1 equals new. Oh, stop that. What are you doing? And actually want to look at the constructor for this. Pull it over here. So our activity context, that gets passed in from the test. Whoops. So let's take a look at what the activity context we're using is test activity. And we also need the failure message and the rule definition. So, activity context, activity context. Name must be at least 5 characters long. No. We don't have that ability yet. Must be at least 21 years old. And rule definition. So new rule definition. And in reality, we're going to do this a little differently. Rule name. Must be at least 21. Subject type name. I'm not going to do test sample class. I am going to do type of test sample class.name. property name is age, name of, do I have birth? What else do I have on that class? I do have age. I need to look at rule definition as well. So back into here. Pull this over here. So I've got the rule name, the subject type name, property name, property type name is type of int.name. I need the operator kind name is operator kinds dot greater or dot toString, because this needs to be stringly typed. Finally, the comparison constant is 21. Okay. And then after this, rules.add min age rule. Oh, right. It needs the key, and the key is the subject type. String rule dict key value equals name of or type of test sample class dot name and there's some stuff I gotta do. Rules.add there we go. And we're just going to cover one type in our tests here for now, because we really don't need to test multiple type dictionaries yet. But when we do, we can always expand these tests. So we have one rule in our dictionary, and this is an awful lot of code to step through. It's connected to the test activity, and it checks to see if the subject is at least 21 years old. So, rule definition, validation tests, test activity, John Doe, pass valid subject, and let's go back to our tests. Boop. And let's just run this guy and see what happens. I might have screwed something up. I probably did. I almost expect it. it failed. I'm not terribly surprised. I wrote a lot of code. So, close this. Close this. What's the error? Oops. Okay, we expected true, we got false. All right, that's fine. But, let's see. Why don't we go ahead and... Oh, we need to pass some stuff here. Rule access equals new fake rule access. And let's take a look at the constructor for the validator again one more time. It needs an IEnumerable of something, of type. So, type array, types to check. Let's do that. And we'll call the correct constructor. Save that. And we'll scooch back to the start of the line. We'll do this. And let's debug. What's that little starry thing? Fix test failure. Yeah, you don't know how. And let's debug that test. It's going to stop right there. Good. We can step over the first two bits of a range. But I want to step into the new constructor. And let's initialize these rule sets. Subject type names. We have one string. And let's push that off to the side there so that we've got a little bit more visibility into what's going on. And let's go into load rules. Make sure our dictionary has some stuff in it. Good. And we're just going to list of T-filtered rules. So our type name here that we're looking for is the test sample class. There should be at least one rule, or there should be a value for test sample class in our dictionary of rules lists. Great. Now, our rule here is a validation rule definition. The type of T here I feel like I want to step up my call stack here. Okay, we are looking for validation rule definitions. Good. So step over this. Good. We can add this to the filtered rules. finish with the loop, return the filtered rules. Now, for each of these, we've got our activity context, our failure message. We've created our rules utility rule definition. We've converted that into a rule. Added it all to our validation rule. Construct our rule set key. Test sample class, test activity. We've initialized our rule sets. Class under test, sample subject, expected is valid. And let's step in here, because now we've actually got rules. So we should see a rule set. Oh, looky there. Rule.execute, out property error equals false. That's true. Result should be validation engine result. Does it have warnings? Nope. And our test, I believe, whoops, has passed. So that's cool. Now I want to check the exact same scenario. But I think what I want to do, instead of having to run this fake rule access constructor every damn time I run a test, I'm going to move it up here. And I'm going to go private rule fake rules access is that. I also want to private validator no rules validator equals that. Private string array types is that. Private validator configured validator equals okay. I wonder if I can make this static. Fake rules access. Dot as enumerable. What are you complaining about? Now what are you complaining about? That's goofy. Here's that. Now what are you complaining about? Generic list of string to all. Type. New list of type. And instead of the type name, I need type of test sample class. There we go. Not configured validator. Activity, no rule set, expect warning, equals not configured. Down here, instead of setting up all this nonsense in the test, we're going to use the configured validator. So there's that. Now, we got to test the other side of this condition. So I'm just going to paste this and we're going to alter things. Pass not valid subject. Expect is valid false. So the expected is valid should be false. And instead of the birth date being 2000, because that would make them 23 right now, let's say 2020. You know what? No. I'm going to say date time dot add years datetime dot now dot add years, and let's say -18. Oh, don't need the line terminator there. Expected is valid equals false. Save that. Refresh our test list. Also want to I don't really want to test the data on this. I just want to test that it's coming back false. Yeah, let's just run it. Run them all. Because I did make some modifications to how the tests work. Okay, and we passed our not valid subject, came back false. Life is good. Now I do want to see what that result looks like when it comes back from being evaluated. And the result. Good. We've got a list of errors. We have a property error against age. It's a full-on error. Must be at least 21 years old. Cool. This makes me grin. Now, through all of this stuff, you've seen me building out these validation rule definitions and the rule definitions and all this stuff manually in code. And there's not a ton of value to being able to do that. If you're going to go to all that work, might as well just type in a series of if-then statements and build out your validation, your property error collection completely by hand and in code. But what if instead of this read-only dictionary that we populate in the constructor with the rules, what if when we call into load rules, we run a query against a database or a storage table or something like that, and then add something like public bool store rule of t rule to store, not tool to store but rule to store, where t is an iRule resource, and off we go. And then we can build a funny little UI somewhere as a web app, maybe in our administration console or whatever. Could just be an API that we curl into, doesn't matter. That we can invoke store rule, and we can create brand new rules in our storage resource from whatever. Or we could just go directly to the storage resource and type the rule definitions in one at a time, but that's a bad practice. But it'll work when you're just trying to get something up quickly. And we've got a whole bunch of flexibility. And we'd be able to review which rules apply to which types for which activities. And all of that stuff. So this little construct here gives us an awful lot of power. An awful lot of power to make our systems really, really flexible without having to go in and actually touch the code, as long as our rules are like simple property, compare a property to a known value type thing. When we want to compare a property value to the value extracted from another property, that gets a little weird. But I'm sure there's a way we can overcome it. And when we run into the need for that, we'll be able to extend this rules utility so that we can do those types of operations. Perhaps we add to the definition that the value needs to be provided at execution time so that we can validate this thing against this other thing of a different type that's going to act as like the source of the validation values or what have you. It's really hard to think of all of the different things that we might want to do in the future. So we're going to do as little about those right now as we possibly can. But for now, I know I'm going to want to store these definitions somewhere eventually. But do I know exactly where yet? No, not yet. I think I'm going to leave it to whoever uses this system to actually implement the concrete rules access for their own system. This just gives them a little bit of a guidepost to get them there. And that's our morning. I think I don't really see any need to continue testing this stuff out. I might add a different activity context or a different class or something like that as I run into situations where I want to get that confidence around things. But I think this afternoon I can actually return to doing the GitHub stuff around that admin application. So until then, I wish you happy coding. Take care, everybody.